Okay, today we're working on 10.5 part 1, multiplying with more than one term, and rationalizing denominators is what we're going to do in part 2. So our objectives is to multiply radical expressions with more than one term, and we're also going to use polynomial special products to multiply radicals. Special products is difference of squares and the sum of two squares, I think, and the difference of two squares. So let's look at example 1, which is multiplying radicals. This is going to be the distributive property with radicals. So we're going to take square root of 7 and multiply it by both the x and the square root of 2. So you take square root of 7 times x. That is x times the square root of 7 plus the square root of 7 times the square root of 2. You can multiply underneath radicals. That's going to be the square root of 14. And we cannot simplify this anymore. So that's going to be our answers. Or our answer, I should say. Let me work on my pen and get it a little skinnier here. Okay. For b, we're going to take the cube root of x and multiply by the cube root of 6, and we're also going to take the cube root of x and multiply by the cube root of x squared, distribute again. So when you multiply cube root of x times the cube root of 6, you can multiply them and you'll get it underneath the cube root. It's just going to be 6x underneath the cube root. So it's the cube root of 6x, and we're going to have cube root of x times the cube root of x squared, so minus the cube root of x cubed when you multiply those two. And we always have to make sure after we multiply that we can't simplify things any further. The cube root of 6x, that's not going to go any further. There's no cube root of 6, and we can't take the cube root of x to the first power, but we can take the cube root of x to the third power. So that second one, we're going to have the cube root of 6x here. The second one's just going to become minus x, because the cube root of x cubed is just x. Now let's look at c. We've got a binomial times a binomial, which means we have to FOIL or do the box method. Some of you guys did the box, and that's fine too. You can use that, but I'm going to show FOIL. So we're going to take 5 times the square root of 2, and we're going to take that times the 4 times the square root of 2. The numbers, the coefficients, the numbers in front of the radical, we can multiply. 5 times 4, that's 20. And the radicals themselves we can multiply. 2 times 2 is 4, so it'll be 20 times the square root of 4. And then we're going to take 5 times the square root of 2 times a negative 3 times the square root of 3. That's going to be the 5 and the negative 3 we can multiply, that's 15. And the square root of 2 and the square root of 3 we can multiply, that's the square root of 6. Maybe I'll get a 6 out of this. Square root of 6. And now we're going to take the next term, 2 times the square root of 3, and times it by each one on the second binomial. So 2 times the square root of 3 times 4 times the square root of 2, that is 8 plus 8. Nope, not a good 8. Plus 8. Then 3 times 2 is 6, so square root of 6. And then we're going to take the last terms and multiply them. The 2 times square root of 3 minus 3 times square root of 3 times those two things, we're going to have minus 6 square root of 9. Alright, so now we're going to have to do some simplifying. Square root of 4 is 2. And so this is 20 times the square root of 4, so really when we take the square root of 4 and get 2, we're going to have 20 times 2. And then we got minus 15 and plus 8, both with square roots of 6. We can add these together. That's going to give us, so we're going to add these. That's going to give us minus 7 square root of times the square root of 6. When we add square roots, we don't change the square root. They got to be like square roots, by the way, to add or subtract. And then we got minus 6 times the square root of 9. That's minus 6. And the square root of 9 is 3, so minus 6 times 3. Now we're going to do our multiplying. 20 times 2 is 40. We still got minus 7, square root of 6. And minus 6 times 3 is minus 18. And now we're going to add our like terms. We got a 40 and a negative 18. We can add those together to get 22 minus 7 times the square root of 6. Okay, checkpoint 2 is, or checkpoint 1 is on the next page. Let's go to the next page, try that, pause here. When you come back, I will give you the answer. Alright, checkpoint 1. The answer to A is x times the square root of 6 minus 2 times the square root of 15. The 60 will break down. Square root of 60 will break down. B is y minus the cube root of 7y. And C is 36 minus 18 times the square root of 10. Those are the checkpoints. Let's look at example 2 now. Move this up. Now we're going to multiply using special products. The special products really comes from the sum and difference, multiplying the sum and difference of binomials, which is really the difference of squares. That's B and C. There is a special product for A, but you don't really need it. You just need to know that square root of 3 plus the square root of 7 squared means you've got the square root of 3 plus the square root of 7 times itself. So square root of 3 plus the square root of 7, another one. If you know that, then you can FOIL. So we're going to take the square root of 3 times the square root of 3. That's going to give me the square root of 9. And then the square root of 3 times the square root of 7 is going to give me the square root of 21. And we got a square root of 7 times the square root of 3. That's another square root of 21. And we got a square root of 7 times the square root of 7. That's the square root of 49. Now, a couple of these we can take the square root of, and the 21s we can combine. Square root of 9 is 3. We got a plus 21 and a plus 21. That's really a plus square root of 21 and a plus square root of 21. That's really 1 times the square root of 21 plus 1 times the square root of 21, which gives us, we add the 1s and get 2 times the square root of 21. Plus the square root of 49 is 7. And 3 plus 7, when we add like terms, is 10. Plus 2 times the square root of 21, and we're done there. Okay, that's A. I'm going to draw a line to separate this out. B, when you multiply the sum and difference of binomials, it's called the difference of squares. When you factor, it's called difference of squares. That rule says, I'm going to write it above here, is A plus B times A minus B. That comes out to A squared minus B squared. So both B and C, we have this situation. It makes the problem a lot easier. Okay, A is representative of the first term in each binomial. B is a representative of the second term of each binomial. And so if we look, the first terms are both A's, or both square roots of 7, sorry. Those are our A's. And the second terms are both square roots of 3. Those are our B's. And to get our answer, we just have to take A squared minus B squared. So we got to take the square root of 7 squared minus the square root of 3 squared. If you square a square root, they cancel out. You get 7 minus 3, which is 4. It makes it a lot easier to do the problem when you have that special product formula. Okay, let's look at C. Same situation. This is our A. Their square root of A's are first in both terms. Our second terms are B's. The square root of B's are the same in both second terms. To do A squared minus B squared, we're going to have square root of A, that whole thing squared, minus the square root of B, that whole thing squared. Square root cancels out with the squared. They're inverses, so you just get A minus B. Pause here, try your checkpoint. When you come back, I will give you the answers to the checkpoints. So checkpoint 2, A is 11 plus 2 times the square root of 30. B is 1. And C is A minus 7. That's all for 10.5 part 1. I will see you in class tomorrow to get your assignment.